Here we will start with question number 22. Arrange S, P and D subcells of the cell in the increasing order of the effective nuclear charge experienced by the electron present in them. The nuclear charge is more in the lower cells close to the nucleus. So this is D is less than B is less than S. So S is having more effective charge. Show the distribution of electrons in oxygen atom, atomic number 8, using the orbital diagram. So this is the orbital diagram of the oxygen. You see here, you see 1s2, 2s2, 2p4. See, first you have to fill up one electrons in the positive spin, then after that negative spin will come after filling all the orbits. Nickel atom can lose 2 electrons to form Ni2 plus ion. The atomic number of nickel is 28. From which orbital will the nickel lose 2 electrons? So this is the Ni. So you see, so it will lose from the 4s2. So it will lose from the 4s orbital. Which of the following orbitals are degenerate? Degenerate means same energy, N plus L. So here 3D, 3D, 3D. These three will have the same. So they are in the degenerate, and this 4D, 4D, 4D. These three are degenerate. Calculate the total number of angular nodes and radial nodes present in the 3b orbital. 3b orbital n equal to 3, p n equal to 3, l equal to 1. So the angular nodes l equal to 1. So L equal to 0 means yes, L equal to 1 means P. For radial nodes, N minus L minus 1. 3 minus 1 minus 1 is also 1. Arrangement of the orbitals on the basis of the energy is based upon the N plus L. That is the energy level value. Lower the value of N, lower the energy. For orbitals having the same value of N plus L, the orbital with lower value of N will have the lower energy. So here based on this N plus N rule, we arranged the orbital like this: 1s, 2s, 2p, 3s. Here you see this 2p and 3s have the same energy. Okay, but because the principal quantum number 2 is less here, so 2 comes first, then 3 comes next. Because here you said for orbital having the same value of N plus L, the orbital with lower value of N will have the lower energy. So here 2p orbital having the lower energy principal quantum number. N equal to 2 here, N equal to 3 here. So this 2 comes first in the same energy level. See, for other things also listed here. Here see 2p and 3s are the same energy level, L plus N. In case of lower value of N, will have the, in this case lower value of N will have the lower energy. We have to arrange the electron from lower energy to the higher energy. Based upon the above information, solve the questions given below. Which of the following orbital have the lowest energy, N plus L? So this is N equal to 4, L equal to 2, 4 plus 2 6, 4 plus 3 7, 5 plus 0 5, 5 plus 1 6. So here lowest is 5s. Which of the following are the highest energy? So here 5 plus 1 6, 5 plus for dl equal to 2 7 8. So 5f is in the highest energy. Which of the following will not show the deflection from the path on passing through the electric field? Neutron, because it's a neutrally charged. Neutron is a neutral charge, so it will not have any deflection. An atom having the atomic mass number 13 has 7 neutrons. What is the atomic number? Atomic number equal to number of protons equal to number of electrons. So the atomic mass equal to protons plus neutrons. So we have to, from 13 we have to subtract 7 to get the atomic number, that is 6. Wavelength of different radiations are given below. Arrange them, the radiation increasing order of their energy. Increasing order of the lowest energy comes first. This wavelength is inversely proportional to the energy. Okay. So more wavelength means there is a less energy. So increasing order means less energy will come first. So here among these, the less energy is micrometer. This is a nanometer. This is shorter wavelength. This is more higher wavelength. So B comes first, then A, then C and D. Okay. See here, the energy is inversely proportional to the wavelength here. See here. So that is enough. You don't have to do any calculation. More wavelength means less energy. So that will come first. The electronic configuration of valence shells of copper is 3d10 4s1 and not 3d9 4s2. How is the configuration explained? See this, as I said, this completely filled and half filled orbitals having the extra stability. See here, half filled and fully filled degenerate orbitals acquire extra stability. That is why copper is having that configuration that I also showed in the periodic table. From the periodic table you can see copper has exceptional electronic configuration. The Balmer series in the hydrogen spectrum corresponds to the transition from 2 to 3, 4. This series lies in the visible region. Calculate the wave number of the line associated with the transition in Balmer series when the electron moves to n equal to 4. Okay, so see, we have to use this formula to compute that transition from the calculate the wave number. Okay, we have to use this formula. See, using that formula they computed the wave number like this. According to the de Broglie, matter should exhibit dual behavior, that is both particle and wave-like particles. However, the cricket ball of mass 100 gram does not move like a wave when it is thrown by a bowler at a speed of 100 km per hour. Calculate the wavelength of the ball and explain why it does not show the wave nature. Wave nature cannot be detected for shorter wavelengths. Okay. See, the wavelength associated with the ordinary object are so short because of their larger masses that their wave properties cannot be detected. Okay, this is given in the book. Okay, they are computing the wavelength, and the wavelength is so short though the wave nature cannot be detected. The wavelength computation formula is given here. What is the experimental evidence in support of the idea of the electronic energies in the atoms are quantized? The Bohr explained this, but we don't know what is the evidence in this. So you can find out yourself. 35. Out of electron and proton, which one will have the higher velocity to produce matter waves of the same wavelength? They explain. Okay, the being the lighter particle, electron will have the higher velocity. Electron is a lighter particle, so higher velocity. A hypothetical electromagnetic wave is shown here. Find out the wavelength. Wavelength means one cycle from this peak to this peak is the wavelength. Okay, so they are given only 1/4 of this. See, this is one portion. There are two portions here also, and there is one more portion. So you have to multiply it to 4. From this peak to this peak is the wavelength, one cycle. So multiply 4, you will get 8.64 picometer. Chlorophyll present in green leaves of the plants absorbs light at this frequency. Calculate the wavelength of the radiation in nanometer. Which part of the electromagnetic spectrum? This. So you have to compute the wavelength like this. This is velocity of the electromagnetic wave in vacuum, and the bottom is the frequency. So using this formula, you have to find out the wavelength. So they found the wavelength as 649.4 nanometer, and this is falls under the visible spectrum. See here, this is the visible spectrum. So it starts from 400 nanometer to 750 nanometer. So this is part of the visible spectrum. What is the difference between the orbit and orbitals? Orbit and orbitals. Orbital is a quantum model of the electron. Orbit is given by the Bohr's model. So here they have explained what is orbit, orbital, and it's important. You can go through it. Table tennis ball, mass of 10 gram and speed of 90 meters per second. The speed can be measured within the accuracy of 4%. What will be the uncertainty in the speed and position? See here they are given how to compute this uncertainty here. So you can use the same way to compute the uncertainty. So using the same formula, they are computing uncertainty of the speed of the fall like this, uncertainty in position. So you can do the same way. Okay. The effect of uncertainty principle is significant only for the motion of the microscopic object and is negligible for the macroscopic particle. Justify the statement with the help of the suitable example. See, effect of the Heisenberg uncertainty principle is significant only for the motion of the microscopic object and it's negligible for that of the macroscopic object, and they given the proof with the explanation here. You can go through it. This can be seen from the following example. So you can go through this example and learn. Hydrogen atom has only one electron, so mutual repulsion between the electron is absent. However, in the multi-electron atoms, mutual repulsion between the electron is significant. How does this affect the energy of an electron in the orbitals of the same principal quantum number? When there for same principal quantum number, the energy will depend upon the L. So the energy is L, N plus L. So L can be S, P, D, F. Match the following species with the corresponding ground state electronic configuration. For copper, as I already shown you, copper is this is C 3D10 and 4S1. Here you see copper 2 plus. This is T. It loses 2 electrons. Zinc A, chromium E. Okay, match the quantum numbers with the information provided by this principal quantum number, energy and size of the orbital, azimuthal quantum number, shape of the orbital, magnetic quantum number, orientation of the orbital, spin quantum number, spin of the electron. Okay, these are the matches. Match the following rules with their statements. First rule: the pairing of electrons in the orbitals belonging to the same subshell does not take place until each orbital is singly occupied. That is, you have to fill up the one electron first in each orbital, then only pairing will start. Aubau's principle. In the ground state of the ground state of the atoms, orbitals are built in the order of their increasing energy. Okay, Pauli's exclusion principle. No two electrons in an atom can have the same set of 4 quantum numbers. Heisenberg uncertainty principle. It is impossible to determine the exact position and the exact momentum of a subatomic particle simultaneously. Okay, match the following: X-rays frequency, ultraviolet rays, long radio waves, the microwaves. Match the following: photon exhibits both momentum and wavelength. Electron exhibits both momentum and wavelength. The probability density always positive value. Principal quantum number. N means so n can have any value. So A4 also principal quantum number, and C always a positive value. That is correct. Match the species given in the column 1 with the electronic configuration. So for the element AR they are using as a base, then above that they are doing. Okay, for C or chromium D, this is given in the periodic table in your book. Okay. So here it is given. Okay. See the AR 2, 10, 16. Then above that they are adding on the orbitals. Okay, these are the matches. Assertion and reason type. All isotopes of a given element show the same type of chemical behavior. Reason: the chemical properties of an atom are controlled by the number of electrons in the atom. Both A and R are true. R is the correct explanation of A. Black body is an ideal body that emits and absorbs radiations in all frequencies. The frequency of radiation emitted by the body goes from lower frequency to higher frequency with an increase in the temperature. Both A and R are true, but R is not the explanation of the A. It is impossible to determine the exact position and the exact momentum of electrons simultaneously. The path of the electron in an atom is clearly defined. A is true, but R is false. Okay, so you can go through the book and answer these long answer types. The important thing is, for every formula the units are important. So you have to take care of the units while solving the formula.